Okay, folks, I'm back after a while for recording, but you wouldn't notice it because I post randomly. But you see that again, I have a lot of light in my glasses, and I'm actually not going to bother with the aesthetics. Should I? Yeah, let's try this. If I turn this way, nah, it's okay. Let's keep going. Stupid things. But anyway, some people are not happy when I am not careful about the aesthetics, but sorry, folks, just focus on the content. Beyond the thermometer, 5 heat metrics that drive better decision making. This is a nice short report by the World Resources Institute, WRI, and I like this. I was just in a meeting with Harvard University in New Delhi, India, and they were here because they are really worried about heat killing millions of people in India by 2047. Well, that's true if we don't do anything, and pretty much impossible that we will not do anything, and that we are already doing a lot of things because uh, the government does worry about disaster management, heat risks, extreme events, floods, droughts, landslides, etc. Cyclone predictions have gotten better, but nonetheless, we do need to pay attention to the best heat metrics in terms of just um, dealing with the event as it happens. The way scientists and policymakers measure heat as they seek to combat rising temperatures across the world's cities require more nuance than just looking at the daily outdoor temperature. There are a variety of tools that can help show a more complete picture. We talk a lot about the duration, intensity, frequency, and scale of the heat waves that are changing everywhere. You can imagine with increasing greenhouse gases, one of the most direct impacts is, of course, uh, warming of the air temperatures. But India as a whole on annual trends doesn't show much warming, maybe even cooling over large parts, but that doesn't mean the mean temperature may be actually remaining flat or even cooling, but heat waves can still occur, right? So this is the deadly part. Some measurements like land surface temperature can help compare different parts of a city. Others like air temperature, heat index, or wet bulb globe temperature describe the regional conditions across a neighborhood or urban area. Increasingly, experts look to more complex data known as the thermal comfort indices to show the impacts on people where they live. So wet bulb temperature, you know what it is. It basically cover the thermometer bulb with a wet towel, then the evaporation reduces the temperature depending on the relative humidity. So that tells you how capable the body would be of getting rid of the heat by um, sweating, because the sweat has to evaporate from the skin. If the humidity is too high, that's not going to happen. So there are tolerance issues there, and of course you always do 95th percentile and so on. And India does more sophisticated thing by saying what the background mean temperature is, and then what the exceedances have to be on top, and so on. And wet bulb globe temperature is a more sophisticated, complicated measurement, which basically tries to measure the impact of putting a thermometer directly in the sun, because radiation heat can really burn your skin, but if you stand in the shade it can feel several degrees cooler. So we have to worry about all these sorts of things. After 2024 was recorded as the hottest year on record, researchers project a nearly 3 degrees centigrade or 5.4 degree Fahrenheit rise in temperature by 2100 if we don't significantly reduce global greenhouse gas emissions. Let's not worry about projections right now, because by 2100 the assumptions we make about the scenarios determine how much the range of warming will be. So it's better to just get prepared for warming, and each 0.1 degree warming, 0.1 degree C warming, you want to know what happens in your backyard. So global warming to local temperature predictions are not so easy. This increase would disproportionately impact cities where the urban characteristics such as miles of pavement and lack of green space can add another degree. So that's of course urban heat island effect, and more than 4 billion people living in the cities would be affected by them. This population keeps growing. That's already a projection. As part of the global weather system, extreme heat can span across broad geographic areas, but individual experiences individuals experience it at very local scales. Choosing the best metric to measure a desired outcome appropriately will be critical for cities worldwide to effectively address the challenge of urban extreme heat as temperatures continue to rise. Okay, I'm reading this basically because now is the appropriate time. I'm sitting here in the end of March. Our heat wave season in India is starting, and this year in 2025 we already have had many early heat waves even in Mumbai in February itself. Okay, so this is serious business. The traditional ways of measuring heat, then, when we talk about heat exposure, we are referring to a series of different heat sources that make someone hot. Suppose a person stands outside during a heat wave. Direct radiation from the sun, reflected radiation from surfaces like roads or buildings, ambient air and moisture in the air all contribute to how hot that person can feel. Okay, environmental variables contributing to how people experience heat then are of course the ambient temperature matters a lot. Humidity can make it sweltering and really miserable. Solar radiation, direct radiation versus shade, as I mentioned. Airflow, if it's windy you may feel much better. Radiant heat, so anything that's coming off from the surfaces or buildings, that tends to be in the long wave radiation. And reflected radiation, of course, is reducing the energy absorption. Here are a few other traditional heat metrics, their uses and limitations. Land surface temperature, I'm going to read the whole thing. It's relatively short and this is an important topic, and we'll do it once because we have talked about heat waves already in many contexts, and here I'm coming back to this late because this report just came out. I thought, why haven't I summarized this before? So I'm going to do it now. Anyways, land surface temperatures, LST, is calculated from satellite data and measures the temperature of surfaces including roofs, treetops and roads. LST doesn't mean much to the everyday person, however, because it's easy to calculate anywhere on earth. Researchers use it for scientific heat mapping, and for many years have considered it the go-to for urban heat analysis. So it's a street lamp syndrome. We have data, so we'll look at it whether it's relevant or not. LST is useful though in comparing different parts of the cities and evaluating which surfaces are likely to absorb heat and slowly re-radiate it throughout the day. However, LST isn't helpful for understanding people's heat exposure because it doesn't account for most of the ways humans experience heat. Even if a person is standing on cool grass, they will feel hot if they are in the sun, or if they are in the sun on a warm and humid day. Sorry, I'm getting a phone call. I have to take it. Okay, unfortunately not the call I expected, a spam marketing, but anyway. So we are talking about land surface temperatures and how easy they are to measure, and hence they are used a lot, but they are not as useful. Air temperatures, on the other hand, measure the temperature of the air about 2 meters above the ground. Because it's easily modeled and understood, air temperature is the measurement local news organizations and other outlets use in their reporting. It's measured with a simple thermometer and gives a clear picture of a location's ambient weather conditions minus any other factors like humidity or sunlight that might make a person feel hot. Because air temperature looks at the background conditions, air temperature is an ideal metric for analyzing and comparing temperatures across time. Across a neighborhood or city, though, air temperature can be difficult to measure. Consistent measurements over a wide area rely on weather stations, which can be geographically sparse and expensive to maintain, or on low-cost sensors, which can be faulty and prone to breaking, of course, and sometimes they get stolen. Scientists then have to interpolate the data between observed points and model the temperature distributions across an area. So we tend to grid it because we want to do it at some scale. Now we use a lot of AI to do these sorts of things. However, air temperature doesn't capture other atmospheric or environmental factors like the number of trees that provide shade that can affect how hot a person might feel in a particular area or neighborhood. Plus, it would take some really big, like a body of water or entire neighborhood of cool roofs to significantly affect the air temperature of an area. So, if cities want to address the impacts of local heat exposure, air temperature would not provide enough specificity to inform human scale interventions designed to protect people's health. Okay. Heat index and wet bulb globe temperatures. Then there is the wet bulb temperature and wet bulb globe temperature, WBGT versus WBT, let's say. See, I have trouble saying a word. Meteorologists calculate the temperature. Feels like using heat index, a metric that adjusts air temperature based on humidity. For example, when humidity and temperature are high, the body has a harder time regulating its temperature through perspiration, as I mentioned before. In contrast, low humidity at a high temperature, often called dry heat, would feel cooler because low moisture in the air leads to faster evaporation of sweat, which cools down the body. So you may not even notice that you are sweating because body is quietly evaporating off the sweat, whereas in a humid condition you may feel very sweaty because the body is not getting rid of the of the sweat by evaporation. Heat index can therefore predict how the body will react to the weather on a given day, making it a helpful tool for determining if it's safe to work outdoors or play sports. And we really have to pay attention to people who have no choice but to work outside: vendors, drivers, construction workers, and so on. Wet bulb globe temperature is a similar metric, but it considers direct sunlight and wind speed in addition to air temperature and humidity. This metric can provide additional insight into heat exposure by determining how much hotter a person feels in the sun and with limited breeze. So it's somewhat of a better but more complicated thing. Here is a first prop. A man cools himself under a water spray in Krakow, Poland. Traditional methods for measuring heat don't always take into account how much heat people can feel on a hot day. I've experienced this kind of a setup also in where was it? Was it in Budapest? Yeah, Budapest. And of course India also puts up fountains and hydrants, the fire hydrants are opened up and so on and so forth. Is this the first figure we looked at? No, we looked at one before. Heat index and WBGT are measured with special thermometers or weather stations and interpolated like air temperature. Given that both these measurements account for more variable heat sources, heat index and WBGT are better indications of heat load, which is the cumulative impact of heat from the environment on a person, than temperature alone. But just like air temperature, they don't vary much across space and therefore cannot always account for changes across the local environment. These traditional methods, often used to measure heat sources, do not describe all the dimensions of how someone feels heat or its impact on their health, which can vary widely from person to person. Age and other things matter as well. Pre-existing conditions. Environment, for example, plays a significant role and can change the impact even without a single city. Even within a single city. Your brain tries to stay ahead of itself, and you just use words from memory, and like a muscle memory the brain has, and you just say some words before it's without even thinking whether it makes sense. Residents of downtown Los Angeles, with its crowded city blocks and lack of green space, will experience heat differently than those on the west side of the city, who might benefit from cooling effects of the Pacific Ocean. Sea breeze may bring some dry, cool upwelling waters may bring drier air. Each heat measurement has utility and can inform different interventions, from cool roofs to early warning heat alert systems. However, these traditional methods of measuring heat don't account for full scope of how heat affects people in their neighborhoods. For city officials to ensure their interventions adequately address the growing impacts of extreme urban heat, cities should also use thermal comfort modeling. Okay, it depends really on what scale you can actually provide alerts at. For example, will it be at really individual level, block level, neighborhood level, city level, district level, and so on. Measuring heat with thermal comfort modeling then, when someone stands outside on a hot day, direct radiation from the sun, reflected radiation from surfaces, ambient air temperature, wind level, and humidity are all simultaneously affecting them. Thermal comfort metrics calculate the cumulative effects of these collective heat sources, providing our most detailed assessments of human heat exposure. If, for example, a person walks down an asphalt street with partial shade coverage from trees at noon on a hot, humid day, thermal comfort metrics provide a sense of their heat exposure, combining factors such as sunshine filtering through the tree canopy, the hot asphalt below their feet, and the weather around them. If the person walks back along the same street at 6 p.m., a thermal comfort metric can predict that they will feel cooler because of the longer shadow and the lower air temperature, even if the heat from the asphalt may have increased by the heating through the day. This sounds very nice, but what is the use of this practically speaking? Let's say I'm walking from here to a neighborhood 20 minutes away, and the alert keeps telling me now I'm in red, green, blue, yellow, whatever. What am I going to do about it? So I think we may be overestimating the usefulness of such indices at such details. Nonetheless, thermal comfort is measured using a set of instruments, including specialized thermometers and a wind meter, but more frequently it's calculated using three-dimensional models that consider meteorology, direct and reflected radiation, tree canopy, buildings, land use, and shade. Scientists increasingly use metrics like the Universal Thermal Comfort Index, mean radiant temperature, or physiological equivalent temperature to calculate thermal comfort. Singapore is always a good example for this. In Singapore, for instance, planners model thermal comfort to pilot urban design interventions that reduce heat exposure, including wind corridors, green buildings, and shade that can cool the spaces where people feel the hottest. So this is a good idea where comfort index thermal comfort modeling can help you design environments for people, especially if you want them to drive less and walk more. Then providing such detailed design can help, or bicycle around instead of taking their car or bus or whatever. Thermal comfort metrics are calculated at very local scale in radii between 1 to 5 meters, which capture variations in shade, vegetation, surfaces, and other relevant aspects of a city's design. As a result, thermal comfort indices help scientists not only understand individual heat exposure, but also heat resilient infrastructure that could be potentially used for mitigating the exposure to heat. So you don't want the building to heat up and put people in uncomfortable situations, even though it's designed in a certain way to help mitigate heat. So you want that to be able to manage the heat for you. Modeled metrics are also useful in prioritizing and locating interventions. So you want to provide, let's say, certain gaps between, money is always an issue, right? How much are you going to invest? Singapore is a nice little state with, relatively rich, I would say. Then they can do a lot of things, but how would you translate that to big countries like India or China or parts of Africa and so on? Model metrics are also useful in prioritizing and locating interventions because thermal comfort metrics use modeling. They can show the local effects of constructing a new park, planting trees, or orienting buildings to provide shade to the pedestrians. Modeled air temperature can similarly inform the impacts of scaling interventions like cool roofs across a whole city. Okay. And Singapore never gets cold, so it's okay, but you have to be careful where you also have cold winters. So cool roofs, what will they do in the winter? There are some materials which are sensitive to the UV and other things. Basically, they can act as cooling during summer and heating or keep the radiation during winter and so on. In recent years, improved high-resolution data availability around the world has made it possible to calculate thermal comfort modeling more accurately and cheaply, making these metrics feasible to use alongside traditional methods. Now, scientists and policymakers have more options than when assessing extreme heat. They can choose the right indicator, physical scale, and time period to look at how the city affects how hot people get and how hot they feel. right? So heat can be measured and modeled in multiple ways. To summarize, so here is reflected heat and radiant heat, and this is the land surface temperature that we mentioned. Very easy to measure and map, but may not be very useful. Air temperature, again useful, but not measured at the scales required. Few weather stations here and there can be an issue. Cheap instruments can be an issue. So this is the I can't read my own. I've become old now. Anyway, heat index here. This is the ambient temperature, humidity. So factors matter. Wet bulb globe temperature that we mentioned, it's a sophisticated instrument. Universal thermal comfort. So a wet bulb globe temperature measures direct radiance versus ambient temperature, airflow, humidity, and basically sees how you feel directly in the sun and outside in the shade and so on. Here you look at solar radiation, ambient temperature, airflow, humidity, and also radiant heat and reflected heat. Okay, reflection of radiation from the reflective surfaces is very different than radiant heat. Okay, so then coming to the end, matching the right metrics to local heat goals. As temperatures continue to rise in cities worldwide, interventions to mitigate extreme heat will become increasingly important. This can accomplish a lot of the work before people get sick, so that extreme events don't have to make a lot of people sick by reducing exposure. And with these mitigation techniques, using the right metric to evaluate the impact of these interventions is critical in considering how, where, and when the changes will be effective. Different stakeholders have varied goals related to heat. As they plan for more heat resilient cities with better infrastructure and co-benefits for cooling across sectors, they should select appropriate metrics for measuring and informing these goals. Some policies and projects will focus on protecting human health during heat events, while others might prioritize reducing the formation of ground level ozone, which can really make you sick, or lowering burdens on the energy grids, because if everybody starts cranking up fans and air conditioners, then often peaker plants, solar and wind are intermittent. They cannot turn up power supply whenever you want, so you will run peaker plants, which can be fossil fuels or even dirty fuels like coal, right? Each goal depends on a different kind of heat metric and data to help plan and prioritize its implementation. So here are the potential heat related goals and tracking metrics. So let's read the goal and the metric. Lower citywide temperatures. Air temperature is good. Protect pedestrians outdoors. Thermal comfort indices are better. Set safety limits on outdoor activities. So heat index and WBGT are important. Keep people cool in transit stops or public spots. So thermal comfort indices are needed. Reduce indoor heat exposure and energy use. So air temperature, land surface temperature of the roofs, or land surface temperature of the roofs, surface temperature of the roofs. Reduce the formation of ground level ozone, then air temperature can be a good indicator metric. Okay. Entire cities can experience heat, but so do individuals. So city officials should consider interventions that target heat at a citywide scale to move the needle on an ambient outdoor temperature, while needle on ambient outdoor temperatures, while also prioritizing local to neighborhood scale change to impact people's day-to-day heat exposure. Okay, so finally, just as different metrics are appropriate for different goals, the same is true of metrics for measuring the effectiveness of different interventions. For example, cool roofs reduce heat across a neighborhood, so their effect is best measured by looking at regional air temperature. Shade protects individuals by lowering their heat exposure, so it can be best understood through thermal comfort metrics. As the risks of extreme heat continue to intensify in cities, leaders and policymakers need a diverse set of tools to understand and respond to risks. Simply knowing that it's hot in the city is not enough at all. Choosing the right metric for each dimension of the heat problem can point policymakers and residents toward deeper knowledge of their local challenges and potential solutions. And I must add that we focus a lot on urban centers, but rural areas also experiencing heat, especially with open agriculture, lack of trees, lack of water, and cooling spaces, etc. So that's for another day. Okay, so let me leave this here. I'll post this out of turn because it's timing wise, it's now a good time. It's 27th March here, so we are already having heat waves. So see you in the next topic.